This video will give you the data you need to do the lab on the force of gravity, specifically for questions 6 and 8, which in normal class you would make the measurements yourself, but I'll do them on the video. And to measure the force of gravity, I'm going to be using one of our force meters. Okay? Don't worry about the tape on it. That's just so that to focus on the metric values, which are in newtons, and that's why we have an N at the top. This will measure force in newtons from 0 newtons to 20 newtons. And it tells you whatever amount of force is pulling on the spring or the hook at the bottom, and that's also equal to the force that the hook is pulling on my finger. You can see the hook pulling on my finger. So that's what it tells you. It tells you the amount of force that this hook is pulling with. To measure the force of gravity on an object, we have to do something, a specific thing. We have to perform a specific act, and that is to hold the force meter vertical, put the object on the hook, and then hold it stationary. If you hold it stationary, then the force of Earth's gravity pulling down on the brick is balanced by the force of this hook pulling up on the brick. That's why it's remaining stationary. They're the same numerical value. And as long as you hold it stationary, the value given by this indicator here, that aluminum indicator right there, that will tell you the force of gravity. If you don't hold it stationary, you're not reading the force of gravity. See that indicator is bouncing up and down? I don't think the force of gravity on this brick is actually changing. It's not getting stronger and weaker, and it's certainly not going up to almost zero there. So you have to hold it stationary, and if you do, this indicator will tell you the force of gravity, the Earth's gravity that's pulling down on this brick. So for number 6, what I'm going to do is go through 5 objects, and in each case, I will tell you the mass of the object, which I know because it's printed on these are precision masses from a scientific supply company, and the value of the mass is printed on them. I will hang them from this and measure the force of gravity. You'll see it, and I'll say it, but you won't have to write it down or memorize it, because when I'm done with the 5 objects, I'll put the results on the board, and that'll be a table that you have to copy into your lab. All right, so the first object has a mass of 0.25 kilograms. That's not grams, it's kilograms. Our standard metric unit for mass in physics is the kilogram. Scientists all over the world agreed that for physics it would be the kilogram because that's a convenient value for the things that we play with in physics class. So that's 0.25 kilograms, and the gravity force on it is about 2.5 newtons. Okay? The next object has a mass of 0.5 kilograms, half of a kilogram, 0.5 kilograms, and we get a gravity force of about 5 newtons. Next, 1 kilogram, the gravity force is 10 newtons, and if you've been paying attention, you might be able to predict what values we're going to see next. The next object has a mass of 1.5 kilograms, and we measure a force of gravity of about 15 newtons. Okay, and then finally, I've taped 2 of the 1 kilogram bricks together, so this is essentially 2 kilograms, maybe slightly more than 2 kilograms with the tape. We'll call it 2 kilograms, and we get a force of gravity of about 20 newtons. Put those results in a table. Here's the table, and you need this for number 6 in your lab. I just want you to copy this table, but I also want you to pay attention to a few things, how you should make tables in this class in the future. First, using the word correctly. This is a table, not a graph. If you use those words incorrectly or misunderstand them on a test, you will lose points. If I ask you to sketch a graph and you make a table, it's wrong. If I ask you to make a table and you sketch a graph, it's wrong. A graph is when you draw axes, label them, like so let's say force of gravity and mass. That's a graph, and then maybe we make measurements like that. You might draw a line for it. That's a graph. It has axes. It's like a picture. A table is a set of numbers, no picture at all. This is a table. Your table should be vertical, like the T-tables you learn to make in your math classes, pre-algebra and algebra. And generally, you want to put whatever goes on the horizontal axis on the left column, and whatever's going to go on the vertical axis in the right column. Or another way of saying is this is the independent variable, this is the dependent variable. If you haven't used those words yet, you will hear them in your science classes. Independent is the variable that I chose. I chose these masses and I put together bricks with these masses. We call that independent. The dependent variable depends on this. It seems like when I change this variable by my own independent choice, this changes as if it depends on what I do to this one. This is called the dependent variable. This is the one I did not know in advance. I did not choose these. I measured these. I performed the experiment and measured these. So going into any measurement or experiment, you can fill this column in before you even do the experiment. I knew what I picked. I could fill that in. And this is the column that you find in your measurements. So independent, dependent. Horizontal axis, like this. Vertical axis, like this. So horizontal, this goes on the horizontal axis. This goes on the vertical axis. And you may have gotten in the habit of calling this the x-axis and the y-axis. You want to lose that habit as soon as possible in my physics class and in science in general, because this will often be something other than, this axis here will often be something other than x. In fact, it's almost never x in this class. And this will often be something other than y. Okay, in fact, in this case, look, it's mass and gravity force. So you don't want to call this x-axis and y-axis. That's really bad. You can call this horizontal and vertical. That'd be fine. Or independent and dependent. That'd be fine. And one big reason why you should never call this the x-axis and this the y-axis is that in the next chapter, after forces, we're going to study motion. And we're going to put time on this axis. And we're going to put the position of an object on this axis. And guess which letter we're going to use for position? We're going to use the letter x. So this would be silly. You'd say, okay, I put time, or I put t. I put t on the x-axis and x on the y-axis. Now you're talking nonsense. T is on the x-axis, wait, that's the x-axis, and x is on the y-axis, there's no y. So that's total nonsense to call that the y-axis and this the x-axis. So horizontal and vertical. All right, so here's the table. Use that to do number 6. And now I will do number 8. In number 8, I don't know the mass when I start. I take something, I call this an unknown, because when I start this, I don't know the mass, right? And I'm going to measure the force of gravity on it, and your job in number 8 is to figure out the mass. Okay, so I hang this, your textbook, from the force meter, and I read about 17 newtons. We'll call that 17 for this lab. 17 newtons. So for number 8, your job is to take this result that I got and work backwards and figure out the mass of the textbook.